Okay, so we left off yesterday with how you make alcohols, and so today we're going to talk about oh wait, we did ethers as well. Let's start with ketones. So ketones have still just one oxygen, but now instead of having it singly bonded to carbon with an H attached, we now just have a double bonded carbon, and you'll often hear this group referred to as a carbonyl. And that just means it's a carbon-oxygen double bond, and it doesn't mean anything else about the structure, just that oxygen-carbon double bond. If there is a hydrogen at one end, then it would be called an aldehyde. If that carbonyl carbon is in the middle of two carbons somewhere in a chain, then it is called a ketone. And the reason they're called different things is they have different reactivities and they do different reactions. So it's easier if we divide them into two separate classes rather than keeping them together. So that carbonyl carbon must be in the longest chain. If it's at carbon 1, it's an aldehyde, and we would change the final E to Al. And there's no number attached because when I tell you Al, I'm telling you put it at the end. If it's at any other carbon, it's a ketone, and we change that final N we change it to ONE, and this one would need a number. And so you'll see here, I put a couple examples down, and you see that this one has a common name in parentheses, acetaldehyde, as well as its true IUPAC name, which is ethanal. Just that final E is changed to Al. Here's a 4-carbon long chain. It's on carbon 2. So in this case, we don't need a number because it has to be 2 either way. It can't be on 1. And there is no 3, so it has to be 2. And its name would be butanone. Okay, so the structure of a ketone or an aldehyde gives it certain reactivities, and that makes it have a trigonal planar geometry. It is sp2 hybridized at that carbon, the only carbon really shown. The R's just mean other carbon groups of unknown or unspecified length. The oxygen is somewhat negative and the carbon is somewhat positive. This makes it reactive in certain reactions. And we can react to get a carbonyl group with an alcohol. That alcohol has to have at least one hydrogen on the carbon that we're going to form that carbonyl on, because we're going to remove a hydrogen here, and we're going to remove a hydrogen here, and we're going to form a double bond here. So the alcohol is oxidized to the carbonyl carbon of either an aldehyde or ketone. If this was one carbon and one hydrogen, it would make a ketone or an aldehyde. If it's 2 carbon groups, then it would form a ketone. So an example of that is here we do have a hydrogen on this carbon. We have 2 hydrogens, in fact. So we're going to form an aldehyde. Here we only have 1 hydrogen. I need that 1 hydrogen and the OH, and since it's not at the end, it's going to form a ketone, and this would be propanone. Again, this doesn't need a number because it can only be on the second carbon if it ends in ONE, and this one would be butanal, or not butanal, propanal. So structures can get quite complicated when we have carbonyl carbons. If you look at these, first 2 I put up here are the 2 structures for the human. The one on the right is testosterone. The one on the left is estrogen. You notice estrogen is a dialcohol or a diol, whereas testosterone is not. But their structures are very closely related. Here is a ring that we could have, and again, this one would not need a number because that one's going to be carbon 1. It's going to have to end in ONE, so it's hexanone. It can't be anything else. You could draw with that double bond oxygen on any of the carbons, it'd still be hexanone. This one, the longest chain when naming an IUPAC, should have the carbonyl on it. And so this is 2 carbons long, so it would be an ethanal. And so it would be 1-cyclohexyl ethanone. So here are some kind of interesting, at least I thought, ketones or aldehydes. Formaldehyde is a biological preservative. It's actually no longer used because it's so reactive and it's very toxic. Cimaldehyde is a common name, but it is the component that gives cinnamon its distinctive flavor. Citral is an antiseptic. It's also used in perfumes, and it has this final HO is your aldehyde. Here, this is benzaldehyde. It's used in making dyes. It's in cinnamon flavoring. And then here's vanillin. It's also a flavoring. And we have the OH out here. Of course, none of these have I given you the actual IUPAC name. But the variety, as you can see, is quite vast. So anyway, that's it for today. Kind of a short, easy day. I'll see you soon.